Good morning. Today in Calculus 30, we're going to talk about transformations of functions. We're going to use some of the knowledge from Pre-Calc 30 to help us out today. In Pre-Calc 30, we looked at taking an original function, a base graph, and applying transformations to it. The parameters a, b, h, and k would change our original graph in many ways. We often used mapping to change individual ordered pairs to find out where the new point would be so that we could see the new graph. But let's talk about what A, B, H, and K would do to a graph. The parameter A is in control of a vertical stretch by a factor of A units when that A value is positive. For example, if I had a positive number out the front of the function, that would be an A value of 2, and we would say that we have a vertical stretch by a factor of 2. So our graph would be twice as tall. In calculus, we do change some terminology and we talk about vertical compression by a factor of A when A is a fraction. If we had 1/2 multiplied outside the front of the graph or of the function, we might say that we have a vertical compression by 2. The word compression implies that it is getting smaller by twice of a factor. In pre-calc, we use the word or the phrasing vertical stretch by 1/2. Either one of these is perfectly fine to describe what's changing to a graph when we have an A value of 1/2. If we had a value of A that was negative, we had ourselves a vertical reflection. So if we had a negative number out the front, a vertical reflection over the x-axis. The parameter B was in control of horizontal stretches. If we had a factor, a B value that was a fraction between 0 and 1, we would say we had a horizontal stretch by a factor of B. So for example, if I had, and now B is a number multiplied in front of the x. So if I saw a value of 1/2, we would have B being 1/2, but in terms of words, we would say that we had a horizontal stretch by 2. And that was often a difficult thing. In the function, we saw a half. When we saw the value of B, it was a half. But when we switched to English words, we then took the reciprocal and it was a 2. Now, the word horizontal compression implies that it is being compressed, made smaller horizontally, and that occurs when we have a B value that is greater than 1. If we had a 2 multiplied in front of the x value, B would be 2. Now, we may say that we have a horizontal compression by 2. That word compression implies that it's being made smaller. Or we may have said a horizontal stretch by, now we would take the reciprocal when we say stretch because we would need to have something that implies it's being made smaller. Stretch doesn't imply smaller, but the half does. And so again, either one of those is a perfectly fine way of describing a change when we have this horizontal reduction, I guess. Horizontal reflections occur when our B value is a negative. In our function, if there is a negative number multiplied in front of the x, we have ourselves a horizontal reflection over the y-axis. The parameter h controls a horizontal translation or a shift. The c value, when you look in an equation, the c value is going to be inside, added or subtracted to the x. Now, the issue with the c value is, I have a plus c here, but you see a minus c in the equation. When you pull the c value out of the bracket, out of the x, it changes sign to a positive, and that implies then a movement to the right. Whereas if you see x plus c in the equation, pulling that c out is going to make it negative. It switches signs. And then we have a graph that is moving to the left. A k value is a vertical translation or a shift. The k value is found at the end of a function, it's added on after the original. And that positive k, no fancy switch in here, the k value is positive, and that implies it's moving up. And if that k value is subtracted or a negative value, then we see our graph moving down. So those are the things that we learned in Pre-Calc 30 that we're going to be asked to use today with transformations. Let's see specifically the kind of questions that we're going to be asked to do. We're going to be given a function. In this case, we're given a parabola. It's an x squared. I can see it has an a value of 1, so it's concave up. It has a constant term of 0. That means its y-intercept is at 0. So I have a bit of a visual of what this graph looks like. But our goal is to describe the transformations and determine what the new function would be with the transformations. So the instructions we're given in the first example here are saying to take our function and apply these parameters to it. Well, that means that we have an a value of -1 out the front. That is going to cause a vertical reflection over the x-axis. The value, the +3, is added on at the end. That is a k value. That means our graph is going to move up 3 spaces. So part A is asking us to describe in words the transformation. So that means that we have to describe using English. Using A and K is not enough. But part B is wanting us then to determine the new function. So following the instructions in the question, what this is telling us to do is to apply a negative to the function, and then we'll add 3 on after the fact. So the function I'm replacing with the x squared plus 3x. And then we would apply the negative to the brackets so that we would have a negative x squared minus 3x plus 3 as our new function. Now, how can I check to make sure that I've interpreted the transformations correctly? You can graph the original function, you can graph the new function, and then see if these two changes truly took place. Do you have a vertical reflection? Do you see your graph moving up 3 spaces? Let's try another one here. Part A. Interpreting the transformations, again, I see an a value of 2 out the front. That means we're going to see a vertical stretch by a factor of 2, meaning our graph is going to be twice as tall. We have a c value inside the bracket with the x. When I pull it out, we're going to have ourselves a +3, which means that we are going to see our graph moving right 3 spaces. Part B is saying now to determine what the new function is going to be. So when you take a look at the 2 out the front, that means the 2 is going to be multiplied to the new function. Now what's changing in the function? The original function was x squared plus 3x. But this piece inside of the brackets is saying that we are going to replace the x's with that x minus 3. So what I should be seeing, I'll leave the 2 out the front of everything, is that I'm no longer going to have just x being squared. I'm no longer just going to have 3 being multiplied to x, but what I'm going to put in there is that x squared plus 3x. That was the original function. Nope, I'm wrong again. I tried this once. I better back up. Sorry. What we are replacing the x with is x minus 3. Replacing the x with x minus 3. So in order to have our function simplified, there is some work that needs to be done. I have to expand an x minus 3 times another x minus 3, which I'll do in a second. And I need to distribute the 3 into the bracket, 3x minus 9. So there's a little bit of steps, there's a few more steps to go here. Expanding the x minus 3 is going to give me an x squared minus 3x, and another minus 3x is minus 6x plus 9. And then I will add those to our 3x minus 9. So I have a few more steps to go here still. 2 out the front until I get this simplified. I'll have an x squared. Looks like I have minus 3x, and then my 9's are actually going to cancel. And so what I'm finally left with is 2x squared minus 6x is the new function, where I'm going to see that original parabola we talked about earlier, having a vertical stretch by 2 and moving right 3 spaces. One more. I'm just going to move this one down so that I have some room here. So once again, part A is asking us to describe our transformations. I see in brackets an h value, and when I pull it out, it's going to be the opposite sign. So a negative h means that I'm moving left 3 spaces. And the minus 2 at the end is a k value of negative 2, meaning I'm going down 3 spaces, down 2 spaces. That takes care of part A. Part B. Again, the instructions in this question say to follow this pattern, which means that the function, which was x squared plus 3x, I'm going to put a minus 2 at the end. But before I do any work there, I have to remember that this x plus 3 in brackets means that I'm taking out the x's and I'm putting x plus 3 in their place. So that means that I'm not going to have the x being squared. I'm not going to have 3 being multiplied to the x. What I am going to have in place of the x is the x plus 3. And again, x plus 3 replaces this x. So there is, again, some simplifying to be done here. The x plus 3 that is being squared, I would have to expand. The 3 is going to be multiplied into the bracket to give me 3x plus 9. And then I would have that minus 2 that's still part of the function at the end. Quickly expanding so that I can get my terms. I'm going to have an x squared plus 6x plus 9 that I will then add to 3x plus the 9 and the minus 2. Like terms, I'm going to end up with x squared. Looks like I'm going to have 9x, and then I am going to have a positive 16 at the end. So those are the kinds of things that you will do to work on some transformations to make sure that that is fresh in our mind as to those parameters a, b, h, and k. Have a good day.